Okay, so simplifying algebraic fractions, some revision, grade 9 questions. This is quite likely to appear on the exam paper, so let's have a look. We need to follow the laws of BIDMAS: brackets, indices, division, multiplication, addition, subtraction. Now in this question, I can see here that we have the difference of two squares, and I can see here that we have a quadratic that needs factorising. So what I'm going to do is I'm going to attempt to factorise the quadratic and rewrite the 4x squared minus 25 as the difference of two squares. So let's have a go then. What we'll do first of all is we'll factorise the quadratic. So the quadratic is, let's have a look, 4x squared plus 16x plus 15. Now, the way we factorise this is we draw two sets of brackets like this, write a 4x as the first term in both. We times the first number by the last number. So we want two numbers that times to make 60, but they add to make the middle number, which is 16. And these numbers are 10 and 6. And then what we do is we then cancel down the brackets or simplify them. If possible, the first bracket divides by 2, so we divide it by 2 and we end up with 2x plus 5. And the next bracket divides by 2 as well, so we end up with 2x plus 3. So I'm going to rewrite this now. We have 5 over, this is the difference of two squares, so it's 2x plus 5, 2x minus 5, minus 2x plus 3, divided by, let's create a bit of space here, so from the previous bit it's 2x plus 5 and 2x plus 3 over 7. Now BIDMAS tells us to do division before we do the subtraction. So you've got to imagine there's like a square bracket here, and we're just going to focus on the division part. When you divide by fraction, it's the same as multiplying by the fraction upside down, the reciprocal of the fraction. So we're going to rewrite this as 2x plus 3 multiplied by 7 over 2x plus 5, 2x plus 3. And as you can see here, when we're multiplying, we can cancel terms, cancel common factors from the top and the bottom. So 2x plus 3 cancels very nicely with 2x plus 3. And you're left with 7 over 2x plus 5. So we have the fraction from before, 5 over 2x plus 5, 2x minus 5. And there's a minus there from before. But now we've condensed this square bracket into 7 over 2x plus 5. And what we can do now is we can try and write this as a single fraction. Now, when you're trying to write it as a single fraction, you need a common denominator. The common denominator is not all three brackets times together, unless they're three different brackets. But here you have three brackets, but two of them are the same. So we only need to include the 2x plus 5 once. So the common denominator is 2x plus 5, 2x minus 5. And you think to yourself like this, draw a little arrow maybe if you like. What do you times this denominator by to get to this one? You times it by 1. So you do the same to the top. 5 times 1 is 5. What do you times 2x plus 5 by to get to the denominator? You times it by 2x minus 5. So you do the same to the top. You times it by 2x minus 5. Now, there's still the potential to make a mistake here, because some students will 5 take away 7, but that's not right. Because with algebraic fractions, once you've condensed it like this, you shouldn't subtract like that. The -7 is multiplied by the bracket, so you should multiply the bracket by -7. Also, you shouldn't cancel the 2x minus 5 with the 2x minus 5 because that's not a common factor. It's only a common factor if the terms are like factors in the numerator, but here they're added or subtracted together, so you can't cancel. Okay. In fact, the rule is when you've made it into a single fraction, you expand the numerator, but you leave the denominator alone. Okay, until you get to the very end. Maybe you want to cancel. So if we expand the numerator, we end up with something like this. Draw my little lines, expanding. So it's 5 minus 14x plus 35 over 2x plus 5, 2x minus 5. Okay, and then the final answer to the question, maybe, will be 5 add 35 is 40 minus 14x over 2x plus 5 and 2x minus 5. Now, if you want to, you can actually go one step further and factorize the numerator again. Yep, because there is a 2 that's common. So you can have 2 brackets 20 minus 7x. Doesn't help in any way, but you can do this if you want to. And this is the very, very final answer. But you will get full marks for the previous line. There you go. Next question. Okay, kind of similar to the previous one. So what we're going to do is factorize the 5x squared minus 2x. Sorry, 5x squared plus 2x minus 7 first of all. So we have 2 brackets. We have 5x and 5x. We want numbers that multiply to give negative 35, add to give positive 2. So we can use 5 and 7. So if we have positive 7 and a negative 5, that works. The first bracket divides by 5, so you should divide it by 5, so you end up with x minus 1. To keep the brackets, second bracket is 5x plus 7. Okay. Now, for this second bracket here, I can make this into a single bracket. So let's do that. I'll do that in red. So a common denominator is going to be x minus 3 brackets 2x minus 5. And what you do is you think about the first denominator. You think, well, what can I do to make x minus 3 into this? You times it by 2x minus 5. So you times the top by 2x minus 5 as well. Okay. For the second bracket, the second fraction rather, what do you times 2x minus 5 by to get to this denominator? You times it by x minus 3. So you times the top by x minus 3. And the rule of thumb for this is you expand the numerator, but you leave the denominator. So let's expand the numerator. When you do that, you get 4x minus 10 minus 3x plus 9. And this simplifies to x minus 1 over, and then you've got your 2 fractions, which are x minus 3 and 2x minus 5. So that's great. Now from before, I've still got this fraction here, so times here. 4x squared minus 25. That's the difference of 2 squares, which you can write as 2x plus 5 and 2x minus 5. Earlier on, I factorized the denominator to give x minus 1 and 5x plus 7. And now we have 2 fractions that are times together. So all of these 3 fractions, these 3 brackets rather, belong to the numerator, and these 4 brackets belong to the denominator. Because they're all times together, I can cancel common factors now. So you have a 2x minus 5 in the denominator, which cancels with 1 from the top. You have an x minus 1 in the numerator, which cancels with 1 from the bottom. And what are you left with? Well, in the numerator, you have a 2x plus 5. In the denominator, you have 5x plus 7 and an x minus 3. And this is the final answer to the question. No more cancelling. Next question. So, BIDMAS tells me to do division before subtraction. So, it's a bit like the first question in this pack. I'm going to put some square brackets here. I'm going to try and work out what's in here first. So you have x plus 2 divided by, now, x squared minus 4 is the difference of two squares. That's x plus 2, x minus 2. And remember, dividing by a fraction is the same as multiplying by the reciprocal. So same as multiplying by the fraction upside down. So let's flip the fraction. Now we have x plus 2 multiplied by x minus 3. And in the denominator we have an x plus 2 and an x minus 2. Because they're times together in the numerator, I can cancel here an x plus 2 with an x plus 2. And I'm left with x minus 3 over x minus 2. Now, what do I have? So I have 5 from before minus what's inside the square bracket, which I have now condensed to x minus 3 over x minus 2. Right, so now what I want to do is write this as a single fraction. Well, how do I make this into a single fraction? I need a common denominator when I'm adding or subtracting. But where's the denominator here? Well, think of 5 as 5 over 1. Then a common denominator adds a 1 and x minus 2 is 1 times x minus 2, which is x minus 2. And I don't really need brackets here because there's nothing multiplying it apart from a 1. So what do I times 1 by to get to x minus 2? Times by x minus 2, so I times the top by x minus 2. What do I times x minus 2 by to get to x minus 2? I just times by 1. So I times the numerator by 1. Okay, and don't forget there's a minus here as well. Now the rule is you expand the denominator but expand the numerator but leave the denominator. So let's do a bit of expanding here. So you have 5x minus 10 minus x plus 3 over x minus 2. When you simplify, you get 4x minus 7 over x minus 2. And that's the final answer. And to the last question. So simplify fully. Right, well, the numerator can be factorized. Right? We want two numbers that add together to give 1, but multiply together to give negative 6. Think of factors of 6. You've got 1 times 6 and 2 times 3. I can use 2 and 3 to end up with 1 if I have positive 3 and negative 2. Now I can cancel common factor. X minus 2 cancels with x minus 2. But I need to try and add 1 to x plus 3 over x plus 4. So how do I do that? Well, think of 1 as 1 over 1. And you need a common denominator now. So common denominator is x plus 4. 1 times x plus 4 is x plus 4. What do you do to get from 1 to x plus 4? Times by x plus 4. So you do the same to the numerator. Times the numerator by x plus 4. So 1 times x plus 4 is x plus 4. Now this makes sense, you see. Because if you think about what we've done so far, we've got x plus 4 over x plus 4. Well, that's 1, isn't it? Okay. Plus, what do you times x plus 4 by to get to x plus 4? Times by 1. 2 times the numerator by 1. 1 times x plus 3 is x plus 3. And finally, you simplify in the numerator, simplify in the denominator. There are no common factors to cancel. Remember, a common factor is like this. Brackets are not the same, so you can't cancel, and that's it.